All right, Josh Johnson here. We are going to get started momentarily. This Facebook, YouTube Live, I may post it later on TikTok now that that's the thing I'm on, will focus primarily on the risk of some wintry weather over the upcoming weekend. There is a lot of noise, there is some signal, and we want to help you differentiate between the two. So, with no further ado, we'll get started. Here's the crux of this thing. So there is an upper trough that's going to dig in Saturday night. This will be kind of an upper level impulse, a shortwave trough that's rounding the base of a larger trough. And the exact orientation of that little wave of energy is going to determine if we have anything, rain, snow, any precipitation at all, Saturday night and into Sunday morning. There is some marginally cold air around, right? So that's checked. We've checked that box to some degree, right? I think there are question marks about how cold this gets, but enough cold air and enough moisture to where you sort of start to think, okay, well, this is worth watching. Now, the issue is computer models, right? They show different sorts of scenarios. I'm going to walk you through that tonight in a way that I think smart meteorologists look at computers, which is we sort of start to predict the prediction to some degree, right? What is the trend in this model? Not what does it show me right now? Anyone can look at that. That's not hard. But what is the trend? What is it heading towards? What is it trying to seek out and find? So let me take you into the data here with no further ado. For the model that's getting a lot of attention right now is this one. This is the GFS computer model. I want to make it big so it's easy to see, so that if all this is wrong, you can tell me how stupid I am at a later date. All right, so this is the GFS. This is valid Saturday afternoon. So far, so good. Nothing going on, right? Well, Saturday afternoon, some light rain showers and snow flurries break out across parts of southeast Texas and Louisiana and Mississippi. And then, oh my goodness, would you look at that? Wow, this is valid at midnight Saturday night, and there is a winter storm in progress across the state of Alabama. Whoa, well, that's crazy, right? Then this thing moves on through, and this is crazy to be saying this, but this shows snow again all the way down to the Gulf Coast for the second straight year. Wouldn't that be something? Then this kicks on and brings snow through Georgia, North Florida, on into the Carolinas. So this is clearly crazy, right? There's no way this can happen. Well, about that. So I want to show you the European computer model and what we're seeing with it. And this will be the latest run of the Euro, which is the 18Z run. But then I'm going to also show you something that cycles through the previous run. So I can show you the trend in the European, which is why I'm not completely discounting that GFS idea. I think there's still it still has some dialing in to do, but the concept itself is actually not as outlandish as it might initially appear. So again, this is the European computer model. We'll fast forward here. This is Saturday morning, nothing's happening. This is Saturday afternoon. Sprinkles, very light moisture radar returns. Until this gets down to southeast Alabama. This is now valid at 3 o'clock in the morning, Sunday morning. And look at how close this thing is, right? It ends up, you see this explosion of precipitation into the cold air, and you have a wintry mix of probably sleet, rain, and snow covering a huge chunk of South and Southwest Georgia, the Florida Panhandle, and yes, even some of Southeast Alabama gets in on the mix here. And then the next frame, it just goes hog wild with a big batch of moderate to heavy snow covering most of South Georgia. And then from there, this heads on to, again, up the Carolinas. So again, this is not the GFS. I've seen a lot of people in the weather world talking about the GFS is the drunk uncle at Thanksgiving. And look, it is. I call it that all the time. But that doesn't mean the drunk uncle is always wrong. This is the European computer model. Again, this is valid at 6 o'clock Sunday morning. And if this is correct, you would have a snow and falling and sticking in parts of the Wiregrass and perhaps even back into parts of Crenshaw and Pike. So let me then show you this. This is, again, the European computer model. But what I'm going to do here, I'm going to show you the model trend. So what does that mean? That means what has the model done the last several runs? So Let me walk along with you through this. So this is the run from yesterday morning. Snow back into southeast Georgia, not much. Watch what happens here. This is yesterday afternoon. Pardon me, I don't know what happened there. This is yesterday afternoon. Same kind of concept, really not a lot happening, but watch these last few runs. This is the run last night. This is the run from yesterday evening. Now we've got snow back in Savannah and back down into the Florida Panhandle. This is the midnight run last night. Now that snow is ticked back west. This is the morning run of the European. Now that snow is ticked back west. This is the afternoon run of the European. Now, so there is a clear trend here. 1, 2, 3, 4. Let me do it again. 1, 2, 3, 4. There is a clear westward shift with each passing computer model run in the European. So, look, I'm not saying it's going to snow or not going to snow. We're talking exclusively computer models right now. But the idea that the GFS is totally the drunk uncle at Thanksgiving may not hold a lot of weight here, because the European now is trending back in that direction. And it all has to do with the orientation of the trough that's coming around the bottom of that larger trough. If it is sharper, deeper, and takes on a little more positive tilt, you start to see this. And I actually did a video about this a few days ago that kind of discussed all of this. Now, look, there are other computers that show absolutely nothing. Some of the AI versions of the physics-based modeling shows bone-dry conditions. That's possible. That's still on the table in this. The other thing we want to look at here, something called the ensembles. Think of the computer model itself as a solo vocalist. It's just me singing. It's just you singing. Hopefully it's not me singing. I'm not a good singer. We also have something called the ensemble that's more like a choir. That's a lot of voices. We're all singing the same song, but it helps us see the range of possibilities here. So I will begin with the European ensembles for Montgomery. And look, I mean, there are 50 of them, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of those 50, roughly 20%, show at least some light snow accumulation in Montgomery. Some of them show significant snow accumulations, right? This is the European ensemble valid for Montgomery. Watch this, though. Let me switch over this. I'll show you the GFS ensemble for Montgomery. Now, there are 30 of those, and I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. About half of these hint at the possibility of at least some accumulation of snow, and a few of them have an inch or more. And again, this is in Montgomery. Go back to the data here. So watch what happens when I switch this. Let's go down into southeast Alabama. What about Ozark? Let's look at Ozark here, and look at that. Now, I mean, you've got a pretty significant number of those pieces of data that suggest accumulating snow. And it's the same thing. I'll go back to the European here and switch the European off of Montgomery and onto Ozark. And you end up with a kind of a similar thing. I'll just pick Dothan. I think that'll be it's kind of the same concept here. But look at that. I mean, again, everyone just says the GFS is out to lunch. This is not the GFS ensemble or the operational GFS. This is the European ensemble. This is one of the most accurate pieces of data that we ever use in meteorology. And you've got a mean of half an inch of snow, and you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. That's almost half of the European ensemble, suggesting some accumulation of snow in Dothan. So all that to say, this is very much a thread the needle setup. Cold air is marginal, moisture supply is marginal, but it is not completely impossible that we see some snowfall in the southern, eastern, and southeastern sections of Alabama, Saturday night and into Sunday morning. I'm not going to put it in the forecast yet, because what I want to see the 0Z runs tonight. 0Z is Zulu time. That means those models will be out. The GFS will be out before the 10 o'clock news. The European will come out right after the 10 o'clock news. I got to see those runs, because the runs tonight will start to, the shortwave in question is just now coming onshore up in British Columbia and the Pacific Northwest. So tonight will be the first time that we're starting to get that sampled by the upper air network over the United States. The upper air balloons will begin to sample around that shortwave trough, and usually you see an increase in the accuracy of the modeling by that point. So the 0Z runs tonight, the 12Z runs tomorrow will be critical in determining, is this noise, is this signal, right? To borrow an engineering term there. Is this something we need to really latch onto? Or is this just kind of a weird blip in the data? So, but I will tell you, I don't think we can completely write off the possibility that the GFS actually sniffed this thing out before anyone else, because the European is clearly trending westward in the data, and there's pretty good ensemble support in that mix as well. So that will be the next thing. The next thing is we will start to look for what are we seeing in the computer modeling once we get into that 72-hour range, that 84-hour range. We'll start to get A, better models, and B, that the thing that's going to cause this to happen or not happen will get over land where we can better sample it and better model it, right? So that's where we are on all of this. I know that's a long way to say we don't know yet, but that's the honest truth. Look, I give it to you straight. That's always the case, but I wouldn't write it off just yet. So there you go. Hope you've all enjoyed our time together on this beautiful evening. I'm going to run here in a moment. I'm trying to find, there's a place on here where I can look at comments, which should I even do that? Who knows, right? But I will address all the comments later. I'll go back in and just type you a response to those. But tonight will be critical. We get new data tonight. That will really help us determine, again, is this signal, is this noise? And then tomorrow we will get within range of some higher resolution modeling, which will do a better job in this. So for now, it's a watch and see thing. Again, I'm not even putting snow flurries in the forecast yet. I'm by just sort of nature a conservative forecaster. And our team is too. So I'm not putting it in yet. But I'm not discounting it, and if you are, I think you might be selling this thing a little short, because this is a sneaky little setup, as I said in the video yesterday. So, all right, everyone, hope you all have a wonderful Wednesday evening. I'll do another live update, I'm sure, tomorrow. I'll post videos, reels here on Facebook, we'll post videos on TikTok and Instagram and YouTube as well. So, if you're not following me on TikTok or Instagram, I am Josh Johnson Weather on both of those platforms. I'm also Josh Johnson Weather on YouTube. It's Josh Johnson WSFA on Facebook. All right, everyone. Hope you all have a wonderful evening. Take care, and be sure to watch WSFA 12 News tonight at 10. We'll dive